Welcome to Study Loop.
So in this problem, we are told that nickel metal has a face-centered cubic, which is 4 atoms per unit cell, and has an edge length of 3.53 angstroms. And we're also told that Ni3Al has an ordered cubic, which is just 1 Ni3Al per unit cell, and has an edge length of 3.56 angstroms. And we want to find the densities of these two. So we'll start with nickel metal. First, we'll find the volume, which is just A cubed. So we'll convert A from angstroms to centimeters. So 3.53 times 10 to the negative 8th centimeters cubed. And that equals 4.40 times 10 to the negative 23rd centimeters cubed. Now we'll find the mass. And so we'll take the molar mass of nickel, 58.6934 grams per mole. We'll divide by Avogadro's number, 6.022 times 10 to the 23rd atoms per mole. And then we'll just multiply by 4 atoms, since we have 4 nickel atoms per cell. And then that gives us a mass of 3.90 times 10 to the negative 22nd grams. And so when we find the density, we just take the mass over the volume. So 3.90 times 10 to the negative 22nd grams over 4.40 times 10 to the negative 23rd centimeters cubed. And that gives us a density of 4.0 grams per centimeter cubed. So this is our density for nickel metal. Now we can do the same for Ni3Al. So again, the volume is just A cubed. So this time we have 3.56 times 10 to the negative 8th centimeters, and we cube that to get 4.512 times 10 to the negative 23rd centimeters cubed. We can find the mass in a very similar way. We'll just take the mass of Ni3Al, 203.0617 grams per mole, divide by Avogadro's number, 6.022 times 10 to the 23rd atoms per mole. And this time we just multiply by 1 since we have 1 Ni3Al per unit cell. And that gives us a mass of 3.37 times 10 to the negative 22nd grams. So now to find the density, we take our mass and divide by our volume. And that gives us a density of 7.47 grams per centimeter cubed. So that is our density for Ni3Al.